Hi, my name is Frida Calgren.
I'm Neil Sullivan.
Hi, my name is Mary Palmer.
And I'm Michael Isaacson.
What has probably been the biggest part of the semester is the research. We have spent time digging into the systems of recycling small format, especially of plastic, and come up with a broad overview and accompanying problem statements. For the size and shape, the screens, star, trommel, and shaker within an MRF are currently designed to separate small plastic items and direct them to waste. Therefore, small format plastic is discarded into landfill. What if we had a way to recycle material, no matter the size? For the material, since most small format plastic packaging is made up for more than one type of resin, it is especially difficult to recycle. What if we could recycle all plastics the same? When it comes to the relationship between MRF and producer, there's currently little to no relationship. What if we open up a communication and cooperation within the entire system? We started out by looking into the MRF and specifically what we could do about the size issue. We mapped the system, and as you can see, we realized that most MRFs have a trommel screening to take out everything smaller than 3 inches. This residual goes straight to landfill, and we see this as a missed opportunity for increased recycling. The material has already arrived at the facility, so we should make the most of it. We designed this path within the MRF for the residual to go through a screening machine to separate plastic from other materials, and then this plastic would be returned to the system. We looked deeper and found that there are already machines in place that can separate plastics from other materials. Optical screening uses an infrared scanner that recognizes plastic, and then, as the conveyor belt goes through the machine, there is a valve with the air nozzles. These use air pressure to shoot out the plastic from the rest of the residuals, leaving the plastic on the upper conveyor belt and the rest on the lower one. The plastic can then be transferred back into the system and be separated into the different types of plastic. This machine is something that is already used to separate paper and plastics from each other, but since it has not been used to separate the small format specifically, small format residuals were not getting recycled. We still need to research more intensely the feasibility of the machine and calculate the rate of return for an investment into such a machine. So far, we have concluded that since the process is already in place, specializing it and making it more efficient should be feasible. The next step is to talk to existing MRF facilities for potential prototyping.
Referring back to our system overview, small format recycling doesn't get caught in the MRFs. One solution is to keep small format from going to the machines. We can do this by using reverse vending machines. Reverse vending machines have been used to collect bottles and cans and has been successful in Europe and parts of the US. Our idea was to make a reverse vending machine that collects small format packaging. Brands that are trying to make small format 100% recyclable by 2025 can invest in the machines, and then in doing so, market their brands on the machine. People will collect their small recycling and then bring these to the vending machines that will be placed in the grocery stores. After placing all the recycling in the machine, the collectors are paid based on how much they bring to the machine. Then workers from the recycling centers come by about once a week to collect the recycling, and it'll be entered into the respective parts of the MRF. People that are collecting the recycling will get money for their shopping and feel virtuous knowing that they have recycled their packaging. The grocery stores that have these machines will make them stand out from the competition as a more environmentally cautious company. It would also encourage more customers to come to their store because people can bring the recycling, get paid for it, and then do their grocery shopping all in one place. We know from the bottle reverse vending machines that people will collect recycling in exchange for money. So we see it as a viable option in collecting small format recycling. The next steps are to talk to local MRFs, grocery stores, and to the brands willing to sponsor the machine.
As we know, it is especially difficult to recycle items made up of more than one plastic. A possible long-term solution is bioreactors. Bioreactors are currently common in the medical industry. However, bioreactors currently are not suited for recycling, although a few companies have started to look into it. We chose to focus on trying to figure out a solution that would allow for bioreactors to be used in recycling and not only fix small format, but recycling in general. This is our design prototype. The bioreactors would receive small format waste from consumers and compress them into a reactor chamber that then uses enzymes such as PETs to break down the polymer chains. The main benefactors would be the stakeholders and customers. Stakeholders would be the ones investing and funding the project, and customers would benefit if financial incentives could be introduced, similar to a buyback system. Although this is not a short-term project or goal, the first step to a successful implementation is to create a full outline of a development plan that a company can use to incorporate bioreactors into their recycling scheme. Some next steps include looking for companies to partner with and who could potentially be investors and managers of a project like this. Since the key to the design lies with the enzymatic biodegradation technology, we can provide a development plan for incorporating that. We still need to research the feasibility of such a task and calculate the return on investment for such a product.
Our team has enjoyed discovering different solutions for the recycling process, and we're excited to see where we can go from here. From the whole Microcycling team, thank you for listening.